Hello, so in this tutorial I'll try to keep it simple and fast, so I just want to be focused on the application layer. So application layer, where in here you're gonna have the front ends and back ends. So my suggestion for you is that any type of applications, it needs to be ready to be converted in a poliolithic structure in microservices. So you can still build it with monolithic structure, but it needs to be prepared for poliolithic structure. So the idea is poliolithic. So the idea is, imagine that, well, first of all, you need always to have your code split it in layers. So the presentation layer should be separated from the logic layer, which should be separated from the data layer. So this needs always to happen. Then each of these layers should be organized by module. So each layer should be organized by modules. This means that you should have your codes organized in a modular way, meaning that everything that is related with the user, the registration, the update of the profile, the permissions, to get the details, whatever, should be encapsulated in a module, in the user module. Everything that is related with, in the case that we talked about before in the e-commerce websites, that is related with the product should be encapsulated in the product module. If there are comments or rates, if they are related with the product, should be inside of the products, but maybe inside of a sub module also. So you basically can organize your code by modules and submodules. Something like this. So this should happen in each individual layer. Then let's say that you want to have a module talk with another module on a monolithic structure. On a monolithic structure, you simply include that module inside of the other one. In a poliolithic structure, you cannot do that. So poliolithic structure, you cannot have that, because maybe in a poliolithic structure the modules, it will be independent. So that's the idea. So all modules are independent from each other. So this is exactly the idea. So the main modules, I'm not talking about the submodules. So if, like as I was saying, inside of the product modules, you can have the common submodule, then the action specifically only for the product modules. You can have the rates module, so you can have submodules. But the product module, if it is a main module, the same thing than the user module or the authentication module, it should be separated. So then this gives you the ability to have a centralized system to have the authentication in just one place. Like OAuth, it could be a good example of this. Okay, so the idea here is that if you need it, then you can when you deploy these modules in a poliolithic structure, when you deploy the modules, you can deploy them in different servers. That's the goal of a good structure here. each module are independent and can be deployed in different servers, but automatically they will talk with each other. So each module, what I'm saying is that each layer, or what we can do is when you deploy the modules, you can then decide what are the modules that you want to deploy, and including also the layers. So you can decide that you want to deploy a specific layer to a specific server and other layer to another server, or a specific module with all that specific layers, or only just one layer to a specific server and another module to another server. This gives you the ability of having a poliolithic structure where you can have horizontal and vertical scalability. This is what it is important. So let me give you a simple example that I was trying to explain before. So let's say that the layer, you have a logical layer, the logic layer, and in the layers you can have multiple different logic layers also. So basically I have an article that explains that. Basically, if you open here the tutorials, if you go to blogstore.com, if you scroll down and if you open the documentation, basically here in the layers you have, if you click in our architecture, you can see that basically is exactly this. So we have different types of layers that you can create. You can create multiple different layers, like this is a good example, and then you can deploy each of individual this layer to different servers, and then inside of this layer you have the specific modules. So you have the presentation layer, the data access layer, the logic layer, and then inside of each layer you have is all the code is organized by modules. Okay, so as I was saying, let's say that you have the logic layer A, and inside we have the module user, and then you have the data access layer B, and you have also the module user. So when you deploy one, so you can decide that you want in the server A, you want to have these two in just one server. Let's say that in here you have also the module products, and also here. So in here in server A you decide only to have the module user inside of the server A, the layer, the module and the layer, or you can have something like saying that okay, I want to have then another deployment to have in another server all the logic layer, and then maybe I want to have another in the server B, in the server, in this case in the server C, I want to have the data access layer B. This is another type that you can have. So this is just an example. Imagine that you can have that. So this is how a block store it was created. That's exactly the poliolithic type of structure, which is very flexible. Where, so if you decide to deploy your application in just one server, so the application is ready to talk internally, to only work as a monolithic structure. If you deploy it across different servers, automatically the application updates. You don't need to worry about this. So the application it will automatically update to all these layers to be talking with different protocols. That then you need to decide. So basically how this works. So basically each layer needs to have a broker, and it's the broker that will decide how does it talks to other layers. If it is to REST, to SOAP, internally by just including files and calling libraries. So this is the broker. The same thing then the modules. So if in the module user, if you in this case is a little bit more tricky, because let's say that you have the service in here, you have a controller and the service in the logic layer, and in the data layer you have the repositories. So if you have this in different servers, like in the deployment one, so each module, so each layer, what's happening is that you will have brokers endpoints in the layers that will allow them to call that specific, in the case that's in the service that we call the repository, you cannot call it as you normally do, you need to call it as a service. So you need always to call the broker, that then it will return that specific repository. So every time, so let's say that this, imagine this as SOAP. A good example it is SOAP. But there are other protocols that you can replicate with REST, which are much simpler and easier, or even other the TCP internal protocols that you can use to replicate the SOAP protocol, but in a much more simpler and faster way. So basically, in here, what you're gonna do is you're gonna call the module user inside of the layer A. Basically, can call the broker from the data access layer B, and saying like return to me the repository user. And in here, so just so you can understand, in here the repository user, in here it will really have the database connection. This will be a real GPA entity. In here, the repository that the user return, it will not be a GPA entity. It will be basically an interface. That's how you call it, a facade. This is a design pattern. You can search this on the web. This is a facade that basically what it has the same methods that the GPA entity has, this repository has, but what this does is every time that the logic, the module user, calls any method in here, what this does is the requests to this broker, and then you have, so basically you have here a client broker, and in here you're gonna have a server broker related with the repository user, and that server broker, it will receive that specific request that you are calling, which is basically the function and the corresponding parameters, and will simply include the repository user inside of that client broker, and will simply then call the specific function. Like, so you're gonna have here the server broker for the repository user. So in here what you're gonna have, basically this is the client broker. It will connect through REST, passing the name of the function you are calling and the parameters. And in here you have the server broker for the repository user that receives the function name and parameters, and then call the real repository user from here, where basically what it does is the user repository, it will include in here in these clients the specific file, and in here then it will call, if it is the insert function, it call if the function name, so you need to do like a switch or a if, whatever, if the function name is equal to insert, call it the repo, and passing here the corresponding parameters that you already receive in this broker, something like that. And automatically this structure, it will be automatically ready. So if you create, if each layer has its own client broker and server broker, you don't need to worry about the deployment layer and to convert monolithical into poliolithical structure. So this is very useful for enterprise type of systems. It is a little bit in the beginning, it is a little bit pain in the ass to assemble all this structure, but then it will be much easier, much faster, and it will give you much less concerns in the future. So, but still, okay, even if you don't want to do this, you can always do when you create your own apps. So you can organize your apps based in contexts. So as I was saying, so this gives you the ability, poliolithical structure related with the user, gives you the ability to have a centralized system in just one place. So let's put here, gives you the ability to have, like, example, like off, something like that, simple example. Let's say that you don't want to have this type of structure. Okay, so you can organize these by projects. So you can have an authentication project, which will have all the codes related with the user, with the ads, whatever, the authentication, the managing of that user, and everything that is related with that specific module of the user, and other things if you think that it makes sense to include in this project. Then you can have another project for the products, then you can have another project for, so basically the idea is you can reorganize your logic codes by individual projects. And then you have the clients. So the idea of having this is that then you have the client sides, the front ends, that then it will consume these services from all these projects. So the idea of having this is that in each individual project you can have your own versions. They are independent. In here they are not completely independent, but still they are, if you do this correctly, you can still do this in an independent way. But in here the idea is, if you can decouple your projects by different versions, different type of libraries. So let's say that authentication, that the user module uses the same library than the product module. But let's say that in here you need a more updated version of that library, but that will break something in the products. So if you have different projects, you don't need to worry about that anymore. If the projects are independent, they have their own libraries, they have their own versions, so you can manage them independently. Projects are independent. Versions, libs, manage, deploy, everything, it is independent. It's much easier to manage this. Test units, integration testing. So it's much easier. Logs, monitoring. So it's much easier to do this if the project is much smaller. Then you have everything in a huge project with huge dependencies. No, like it's much easier if you can decouple your project in small projects. So that's the idea. They can still be talking with each other. So inside of a project you can still include another project, or you can have the brokers in case you decide then to deploy later on as a microservice structure. So that's the idea. So you can have multiple ways of doing this. So that's something, so you can think about it. Okay, so this is just an example. So more the decoupled that you have your code, better and easier it will be to manage it, and less risky it will be also. So from the client side, then you can have the front end that will consume all that specific services. If you don't want to have completely independent client sides, then you can have another project here, which could be the front end. for user module, something like that. Or if you want, you can have this inside of the authentication project. If it is this the case, like example, if you have like websites, maybe it makes some sense to have the main panel inside of this project instead of having this as an external project. But it's so both solutions, they are fine. So it depending of your scenario, of your requirements, we need to analyze case to case. There is no absolute decision that you can say, oh, no, it's better to doing like this. No. So it depends of each individual case. But as I was saying, then you can have the front end also in here, split it. Now, when you do the front end, so then all these projects, maybe they should have a shared template, where you should have templates with views. So you can have a standardized way to show all your projects. Because I don't want to work, let's say, a system like e-commerce website where I need to change, I can change my user permissions and all of that information related with the user, and then I can add real products, and imagine that is two different completely templates. That looks like it's two different completely applications. No, I want to have the same template. So, or you share these templates across all these projects. So you can create here another project common, where in here you have the templates, you can have views, something like that, and then you can include this project inside of these projects, or you can have each individual things, or you can simply have like a completely independent client-side projects, where in here then you have the templates and the views, and in here simply consumes the services from the backend. There are multiple different ways of doing this. My point is, you should have inside of the presentation, you should have layers. So your code should be organized, decoupled, whatever, by layers and modules. This is the key concept that you should always have. So first layer, presentation. You should have templates, you should have views, you should have the pages that combine the templates and views and the data that is coming from services or external services, like from the backend services, or that is coming from another library that could be the service layer. So before I was explaining in the backend, so as I was showing here, so in the backend, so we can call this presentation front ends. It depends, because even in the front end you have other layers here. So I don't want to call this as a front end, but in here, so let's call it this here logic. In the logic, then you should have the corresponding services, then you should have the data access layer, where you should have your own repositories, then you should have another layers which will contain your DTOs or your models or your data access objects to be extended on the repository sites, whatever. So you should have multiple different layers. You should organize these by layers. From the backend endpoint of view, you should have the routers, also you should have the controllers. The controllers is what it will basically combine, is basically the page, the part of the pages. You can have the dispatchers also. So all these layers. So one of the advantages of having also all these layers here is that you can add cache. You can add cache in each of individual layer and each individual module. So every time, like this example that I was explaining, so when this client calls this specific broker in here, this server broker, maybe this will return the cache. It doesn't need to call it the specific repository. It will just return the specific cache. The cache in here, or you can have then the specific cache also in here, in the logic side. So each layer should have cache. That's my point. So you can have Then in here you can have like the routers, the controllers, you have the dispatchers. So basically that's you can have then and then all of this, it will talk with specific with the service. In the logic service, the service you call the data access, the repositories. It's just an example. So for the front end is a little bit different, because if you have individual front end, so if you have like so this will be the case that you have all of this together at the same place. If you have individual front ends as a different project, in here you should have also the controllers, you should have also the services. These are the services that will call or will consume the backend services. Then you have all the templates, the views. So in this case it's the controllers that call this. So in this case the controller is, it could be the pages, but it could be something different, because then you can have multiple different controllers that can combine different type of pages. Maybe you can have a controller that simply returns a specific view and template, or just return a specific view without the template plus the data. Or you can have a controller for APIs that simply calls the services and return the specific data in JSON. Or you can have another control that returns in XML, or just one control that receives the type and automatically updates if it is JSON or XML, whatever. So you can have multiple different controllers. So I put here pages, but it is not the same thing. This is just an example, so let's put here example. Or return in JSON, whatever. So this is just an overview, so I'm just remembering these as I'm at the same time that I'm speaking, I am remembering at the same time about this. So this is not a very well structured thinking that I'm currently having, but basically what my point is, you need to think about structure. When you structure your code, you need to have to decouple as many layers as you can to make this simple. You need to have your codes splitted by contexts, by modules, it should be independent. So then you need to, because all of that then it will give you advantages in the future. And then obviously that all these codes needs to be optimized. So the services before called the repositories, so the services so the services before called the repositories, it should have cache, it should check. Maybe we can, in here we have this like internal layer that will be in the server. Maybe this can talk with Redis or some other servers. This we can talk also with maybe some queue system with the MQ protocol, and then the repository is a repository that talks with the database. Maybe the services will decide if connects with one database or another one. If it is depending of the logic, let's say that maybe you can have some logic in MongoDB and also in MySQL. So there are scenarios where this is worth it. You can use it Mongo to store specific things, non-persistent things, or persistence but to be faster to get it from MySQL. There are multiple ways that, so basically what I'm saying is that you need to have, so in this case you should not have just one service that will have all of these. So you'll have a service that will talk with the service B, and that will talk with the service C, and that will call the service D, whatever. So you should have your code decoupled in multiple different actions or logic contexts, whatever. So that's the main idea that I'm trying to transmit here. Yeah, but from the top of my mind, yeah. So the same thing that in the front end. So the front end you need to have your code prepared for that. So if the front end, if it's just consuming specific services, you need to be sure that you have maybe all the JavaScript, if it is React or whatever, in the client side to run then the data correctly. Maybe you can use like some images, the code, the service that will return that, it should be prepared for that, to have just, instead of getting individual images, to get just one image with all the images inside, so you can just do one TCP request. Or you can also do prefetch images before the client clicks in something. You can always prefetch some images. So there are multiple different optimizations then then you can always do. The important thing in here is that you need to be worried about that application layer, front end or back end. You should pay attention to monolithic structures and poliolithic structures. Monolithic structures, be careful, because you'll be stuck. You'll be when the project grows up, then you'll start having a lot of different problems. So ideal is to have a modular structure prepared for poliolithic independent services as microservices, or simply modular poliolithic structure, but doesn't need to be microservices, because microservices always has attention, because not everything should be in microservices, because then you have a pain in the ass with the synchronous processes, and you have the system can get very complex. So all of this needs to be analyzed very carefully. So additionally, you need to be concerned not only about the structure of your application layer, that's what we're talking here, but you should be worried also about test units, logs, DevOps, maintaining the system, monitoring it. So you need to have in your logic code, you need to have all of these implemented. You need to have test units, integration testing, end-to-end testing. You need to have all of these already prepared, so every time you do a deployment, all these things can run automatically, and you can have an automated DevOps system also. So it's important to have your code ready for this also. Additionally, you should have a lot of logs. You should have also you should log also the events, if the services they work fine or not. You should log the exceptions. So there are ways to put this. There are systems where you can call already the specific libraries. Don't try to invent the wheel. So use the libraries that already exist. There are a bunch of things that you can use there. So you just need to call that libraries and pass that specific event, saying okay, with the specific state, saying this service it worked fine or not, why it didn't. Okay, here is the exception, here is the specific value. So you can use data log, which is basically a service, a library that combines, that you can send all the logs from your servers, and then it combines in just one user interface, so you can see the logs all together. Otherwise, if you have multiple different servers, it is a pain in the ass. For the monitoring, it is the same thing. You can use Prometheus with Grafana, where basically is a UI where you can see all the states of workers, events, whatever you insert there, you input to these systems. So your logic code needs to be prepared for this. Additionally, you should also have the auditor installed in your system, so automatically you can have the metrics of CPU, of latency, TTLs, of TCP stale connections, the half open connections. So you can know the speed, the bandwidth, the memory. Then you need to be careful about memory leaks if you are using threads, because of the garbage collector. Attention, if you are not using a system that already has a good garbage collector, you need to be careful to delete the things in memory yourself. You can have a lot of memory leaks. They are apps, they are services that analyze memory leaks also too. You can make all of this easier in a user interface level. You can have also, even if you already, if the system where you are building your application, if already has the garbage collector, the automated garbage collector, as in Java that already does it automatically, or in Ruby also. Even if you use threads, you need to be careful with the shared objects across threads, because that doesn't get cleaned automatically. So it needs to be you to clean that reference, so the garbage collector can then erase and clean that from memory. Otherwise, you'll end up having that forever, or until the garbage collector explodes or restarts. So then you have commands also that can check that memory leaks. You have services that can analyze that for you in a user-friendly way. More. So basically, you need to have your code then with all of this prepared for enterprise level.